Chapter 13. Motion and Time. Lesson Preview. Types of motion. Speed. Measurement of time. Simple pendulum. Units of time and speed. Measuring speed. Distance time graph. If we look around, we find different objects moving. In our previous class, we have studied about different types of motion. Let us recall some important things that we have learnt in the previous class. Motion could be in a straight line or it could be circular or periodic. Measurement is the comparison of an unknown quantity with some fixed quantity of the same kind. The various measurements we make in our everyday life are of length, mass, weight, volume, time, temperature, etc. Units of measurement that could be uniformly used by everyone are called standard units. The standard system of measurement is called the SI system. In the SI system, the various units are length, meter, m, mass, kilogram, kg, time, second, temperature, Kelvin, K, or Celsius, degree Celsius. The other popular systems of units still in use are foot-pound-second system, FPS system, centimeter-gram-second system, CGS system, and meter-kilogram-second system, MK system. Types of motion. The motion of soldiers in a march past or the cars moving on a road is translatory motion. Motion of a pendulum or that of a swing is periodic motion. The motion of the earth around the sun is circular motion. Slow or fast motion. The motion of some objects is slow, while that of other objects is fast. Some objects move faster than other objects. For example, a train runs faster than a car, and a car runs faster than a bicycle. Even the same vehicle may move faster or slower at different times. How do we decide which object is moving faster or slower? The comparison of distances moved by objects in a given interval of time helps us to decide which object is moving faster or slower. Thus, we need to know two things to measure how fast an object is moving. Distance traveled by an object. Time taken by the object to cover that distance. When we say an object is moving fast or slow, we refer to its speed. Speed. Speed is the distance traveled by an object in unit time. When we say that a bike is moving at a speed of 80 km per hour, it means that it covers a distance of 80 km in 1 hour. The speed of bike may not be uniform. It may start slowly and then pick up speed. It depends on the traffic or on the kind of road. When we say the bike has a speed of 80 km per hour, the total distance covered by it in 1 hour is considered. What we actually calculate is the average speed. Thus, speed equals total distance covered. Total time taken. When a body covers equal distances in equal intervals of time, it is said to be in uniform motion. However, if the object moving in a straight line keeps changing its speed, it is said to be in non-uniform motion. In daily life, it is very rare to find objects moving with a constant speed over a long distance, or for long durations of time. Measurement of time. Right from the time we get up till the time we go to sleep, we perform various activities in which we need to know the time. These days we see the time with a clock. In earlier times, there were no clocks. How did people know the approximate time in those days? In the olden days, people used the natural events or phenomena which repeat themselves at regular intervals. For example, time interval between one sunrise and the next is a day. The time interval between sunset to sunrise is called a night. The time between one full moon to another was a month. A year was measured as the time taken by the earth to complete one revolution of the sun. Some devices made by humans to measure time were the sundial, hourglass, sand clock, and water clock. Sundial. Sundial measures time by the position of the sun. The length of the shadow cast by an object will change with the time of the day as the position of the sun will change. One can see the sundial at Jantar Mantar in New Delhi or Jaipur. Hourglass. Hourglass, sand clock, is based on the fact that a fixed time, usually an hour, is taken for the sand to fall from the upper chamber to the lower chamber of an hourglass, having two large glass bulbs connected with a narrow glass tube. Water clock. In water clock, water is used instead of sand with the same principle. Sundial. Hourglass. Water clock. Figure 13.1. Some ancient time measuring devices. The above devices were not very accurate, therefore, a need was felt to have a more accurate instrument for recording time. In 1656, Christian Huygens, a Dutch mathematician and physicist, made the first pendulum clock. It was based on periodic motion. Simple pendulum. A simple pendulum consists of a small metallic ball, or a stone, called a bob, suspended from a rigid stand by a thread. Figure 13.2 shows the pendulum in the rest position. This position is also called its mean position. When the bob of pendulum is pulled to a side and released, it begins to move to and fro at fixed intervals as in figure 13.3. This back and forth motion of a simple pendulum is an example of periodic or oscillatory motion. Rigid support. Long thread. Bob, metal ball. Extreme position. Mean position or center position. Extreme position. When the bob moves from one position and returns to the same position, it is said to complete one oscillation. The path of oscillation could be I, between two extreme positions, i.e. from A to B and back to A, or 2, from the mean position O, then to A to B, and back to O. The time taken by the pendulum to complete one oscillation is called its time period. Activity. Take a string about 30 centimeters long and tie a stone or a small metallic ball at one end. Tie the other end to a rigid surface like door handle or knob, so that it can swing freely without touching any object. Switch off the fan in the room. Mark the mean position of the bob on the floor or on the wall. Release the string attached to the bob from one extreme position and let it oscillate freely. Measure the time it takes to complete 10 oscillations with the help of a stopwatch. In case you do not have a stopwatch, use a wristwatch or a wall clock having a second hand. Note down the reading. Divide the time taken to complete the oscillations by 10. You will get the time period of the pendulum. Repeat the activity a number of times. You can repeat the activity with different number of oscillations like 20, 30, etc. What do you notice? You will observe that the time period is the same in each case. This shows the constancy of time period of the pendulum. Winding clock and wristwatches are refinements of the pendulum clocks. All clocks make use of some periodic motion, whether it is a wall clock or a table clock or a wristwatch. A mechanical wristwatch has a balance wheel in place of a pendulum which serves the same purpose. Nowadays, clocks and watches are electronic. These clocks are called quartz or digital clocks. These watches have quartz crystals which vibrate very fast and at a very precise rate. They are much more accurate than the pendulum clocks. Wall clock, wristwatch, stopwatch, digital clock. Figure 13.4. Some types of clocks. Units of time and speed. The standard unit of time is second. Its symbol is. Bigger units of time are minute, min, hour, h, and day, d. Let us recall 1 minute equals 60 s, 1 hour equals 60 minutes. Since speed equals distance time, the basic unit of speed equals meter per second or ms1. It can also be written as m per minute or km per hour. Note: The symbols of all units are written as singular. Now that we know the units of speed, let us calculate average speed. Example 1. 3 boys A, B and C took part in a 100 meters race. They took 10s, 12s, 15s respectively to complete the race. Who ran the fastest and who ran the slowest? Solution. A covered the distance in 10s, hence his speed equals 110 equals 10 milliseconds minus 1. B covered the distance in 12s, hence his speed equals 112 equals 8.3 milliseconds minus 1. C covered the distance in 15s, hence his speed equals 115 equals 6.33 milliseconds minus 1. Hence, A ran the fastest as his speed is 10 milliseconds minus 1, whereas C ran the slowest as his speed is 6.33 milliseconds minus 1. Measuring speed. Let us measure the speed of a moving ball. Activity. Draw a straight line on the ground, about 2 meters in length. You stand at one end of the line and let your friend stand at the other end. Ask your friend to gently roll the ball along the line from point A to B. Note the time it takes to travel the distance A to B with the help of a stopwatch, and also note down the time it takes when it comes to rest. How much time does it take to come to rest? Repeat the activity 3 to 4 times. Record your observations. Calculate the average speed. You can also calculate the speed of your friend and your own while traveling a fixed distance by walking, jogging, running or cycling. Find out who is the fastest and who is the slowest by calculating the speed in MS1. Motion is dependent on speed. The higher the speed, the faster is the motion, and vice versa. Once you know the distance traveled and the time taken by a moving body, the average speed can be calculated. Similarly, once the speed of an object is known, the distance moved by it in a given time can be calculated. Distance equals speed times time. Likewise, time taken to cover a distance can also be calculated once speed and distance are known. Time equals distance speed. Example 2. The Rajdhani Express covers the distance between Mumbai and Delhi in 16 hours while traveling at an average speed of 90 km per hour. How far is Delhi from Mumbai? Solution. Here, time, T, equals 16 hours speed, S, equals 90 km per hour. Now, distance, D, equals S times T equals 90 km per hour times 16 hours equals 1440 km. So, the distance between Delhi and Mumbai is 1440 km. Cars, buses, and other vehicles are fitted with a speedometer on the dashboard. It records the speed of the vehicle in km per hour. There is another instrument fitted which records the distance moved by the vehicle. This meter is called odometer. It records the total distance traveled by a vehicle in kilometers since it was built. Distance time graph. The motion of an object can be represented by the distance time graph. How to draw a graph? Take a sheet of graph paper. Draw 2 lines perpendicular to each other. The lines represent the 2 axes x-axis and y-axis. Mark the 2 lines as socks and y as shown in the figure. The horizontal line is called the x-axis and the vertical line is the y-axis. The point where the 2 axes meet is called the origin, and is marked as O. All positive values are shown along X and Y only. Suppose while traveling in a car, your friend noted down the distance and the time taken for it to cover that distance. The data is as follows. X-axis and Y-axis on graph paper. Table. Serial number. Time, min. Distance, km. 1, 0, 0, 2, 1, 1, 3, 2, 2, 4, 3, 3, 5, 4, 4, represent the data in the form of graph. Time is always taken along the x-axis and distance along the y-axis. You can now make a graph as follows. Draw two perpendicular lines. They represent the two axes. Mark them as X and Y. Represent time along the x-axis and distance along the y-axis. Next, decide on the scale to represent time and distance. Time, 1 centimeter equals 1 minute. Distance, 1 centimeter equals 1 kilometer. Plot the values of time and the corresponding value of distance given in the table. In the graph, the set of points corresponding to position of the car at various times are shown. Join all the points on the graph. It is a straight line. The graph is called a distance-time graph. If the distance-time graph is a straight line, it indicates that the body is moving with a constant speed, i.e., it is in uniform motion. In other words, a body is said to be in uniform motion if it covers equal distances in equal intervals of time. When the speed of an object is not uniform during the course of the motion, the distance-time graphs are not a straight line. Suppose a car B is in motion. Its values are: table, time, min, distance, km, 0, 0, 15, 5, 30, 20, 45, 25, 60, 40, 75, 45. Follow the same steps as before. It is not a straight line. This shows that the car is in non-uniform motion. Uses of distance-time graph. Distance-time graphs tell us whether an object is having a uniform or a non-uniform motion. They tell us the distance covered by an object in a given time period. We can see how much the car has traveled in say 20 minutes also by plotting the point corresponding to 20 minutes and then drawing a perpendicular line to the x-axis at point A. Then mark point T on the graph at which this perpendicular line intersects. Next, draw a line parallel to the x-axis through point T. This line intersects y-axis at point B. Thus, OB gives the distance covered by the car in 20 minutes. We can plot the distance-time graph of two or more objects on the same graph to compare their speeds. We can also calculate the speed of an object from the distance-time graph.